Okay, 4.12 non-equilibrium applications of Newton's laws. I don't think non-equilibrium is a word. I think it's split up into two, which is why there's a red underline under it. But when acceleration doesn't equal 0, we can apply full Newton's second law. So it kind of goes back to the last video, meaning that the force in the x direction is the summation of mass times acceleration in the x and force in the y direction. So that means we can, this is like simple logic. Like these are force vectors using acceleration vectors. Basically all it means is that you have to add up all the force vectors. That way we can gain net movement, and that's pretty logical. So like if we go back to this example, if I'm pulling this box and I weigh 5 kilograms at negative 6 meters per second squared, and this guy's pulling it at 5 kilograms and at 6 meters divided by second squared, we're applying the same amount of force to it. But let's say that, and we can't use the tension force here because I have to change the mass. Let's remove the box. Let's just say we're pulling a rope, which means I guess the tension force becomes us. And let's say I weigh 10 kilograms and I'm accelerating myself. Which, does that even make sense? Anyways, okay, let's take out the people example. Let's say there's an acceleration vector of, let's say there's a force vector of 5 newtons and a force vector of 5 newtons. These cancel out to become 0 newtons. However, if this was 15 newtons, this would technically be negative 10 newtons. So basically, we can simplify all the forces down into one vector, is basically what this chapter is saying, with the summation notation. And that is it, so that's pretty simple.